right, we're looking at V5, which is division with exponents. I've written the rule here. When you're dividing exponents, just like on multiplication, you keep the base. The difference is instead of adding the exponents, you subtract the exponents. So our instructions are to simplify, meaning come up with one answer, and to express our answer using positive exponents. So number one, we've got d to the negative 7 divided by d to the 9th. So basically what I'm going to do is take d, I'm going to keep my base, and subtract my exponents. So I have d to the negative 7 minus 9. Well, that would be d to the negative 16. But we're told to write our answer using positive exponents, which means since this is a negative exponent, we have to flip it over. So we're going to have 1 over d to the 16th power. Number 2, we've got u to the negative 4 divided by u to the 4th. So again, we're going to keep our base, which is u. Negative 4 minus 4 gives us u to the negative 8. You can place that over 1. You're going to flip it over because we have a negative exponent and we need a positive 1. So we have 1 over u to the 8th power. Number 3, we have n to the 3rd power divided by n to the 2nd. We're going to keep our base, which is n, take 3, subtract 2, and that gives us n to the 1st power. Now this time it's a positive exponent, and that's how we're told to write our answer. So we don't need to do any flipping or anything. We just write it as we have it. And you could have even typed just n if you wanted to. Number 4, we've got m to the negative 9 divided by m to the negative 6. So I'm going to take m, keep my base, negative 9 minus, that's part of what you're supposed to do. What are we subtracting? We're subtracting negative 6. So don't get rid of the negative if you have one. It becomes whatever your number is minus the negative. So we know when we subtract a negative, it actually becomes a positive. So we've got m minus n plus 6. Because minus a negative is a positive. And that equates to m to the negative 3rd power. And again, we can't have a negative because they ask us to write this using positive exponents. So we're going to flip it to its opposite base so that we end up with a positive exponent. So that was 1 over m to the positive 3. Now, I'm taking a lot of steps to show this to you. You're going to get to the point where you don't need to write any of this in between stuff. You're going to be able to go straight from the beginning to the end. So I'm asking you to be patient, bear with me. If you are ready to just go to the end, then go to the end as we work them. So we've got 5, number 5 is w to the negative 5th power divided by w to the 3rd power. So we've got keep the base, subtract the exponents. That gives us w to the negative 8 power. We can't have a negative, so we're going to flip these over. And that gives me 1 over w to the 8th power. Look at number 6. We've got c to the negative 8 over c to the 9th. All right, keep the base, which is c, subtract the exponents, and we've got c to the negative 17. I know that can't remain that way, so I'm going to flip this over, and I end up with 1 over c to the 17th power. Number 7, we've got m to the 7th power divided by m to the negative 4th. Keep the base, which is m. Subtract the exponent, so I'm going to subtract negative 4. That changes to m to the 7th power plus 4, which gives me m to the 11th power. We've got, let's see if I can create some more room here. Number 8 would be k to the negative 3rd power divided by k to the negative 41st power. Keep the base, which is k, subtract the exponent, so negative 3 minus negative 41. So I know I'm adding those two together, and that would give me k, well, 41 minus 3 is 38, and 41 is positive and it's bigger, so that's just going to be k to the 38th power. I think I'll do one more and then we'll call it quits there. So I've got v to the negative 54th power divided by v to the negative 40th power. So keep the base, subtract the exponents. So we've got v to the negative 54th, now it's plus 40, and that gives us v to the negative 14th, because 54 minus 40 is 14. The 54 is the larger number and it has a negative, so therefore my answer is negative. Put that over 1, flip them over, and I've got v, oops, scratch that, 1 over v to the 14th power. Let's go ahead and take a look at this one because this is very interesting. This is number 10. And it might look at it a little intimidating because you don't have an exponent in the top. But remember, when there's not one there, there is an imaginary 1. Here they wrote it because it was a negative 1. They had to write that. Oh, you can't see. There we go. So we're going to do what we've been doing. Keep the base, subtract the exponents. So I'm left with p to the 2nd power. Number 11, r to the negative 52nd power divided by r. Now remember, there's an imaginary 1 here. So I keep the base, which is r, subtract the exponents, and I end up with r to the negative 53rd power, and I'm running out of room. So I know that I can't have this negative 53rd power up here. So I have to change it to 1 over r to the 53rd power. Sorry about that, ran out of room. So you can kind of guess what I'm doing or know what I'm doing based on what we've done before. All right, I'm going to leave this one as our last one. So we've got s, well, this is number 12, I believe. We've got s divided by s to the 83rd power. Keep the base. Subtract the exponents. So this would be s to the negative 82nd power. Flip it over. I don't know why I didn't run out of room on this one, but that would be 1 over s to the 82nd power. That was the last one for this lesson. Hopefully it was helpful. I'll see you on the next term. Bye.